This presentation demonstrates how to use the Straumann surgical cassette. The surgical cassette is designed for secure storage and sterilization of the surgical instruments and auxiliary parts of the Straumann dental implant system. It follows a simple layout with color-coded application pathways. These pathways represent the workflow lines that guide the user through the surgical procedure. The cassette layout is convenient for all the instruments needed for the implantation process. The Straumann surgical cassette consists of three components: the lid, the upper tray, and the lower tray. The preparation of the implant bed is done by using one surgical kit for all Straumann dental implants. The upper tray contains all the devices and drills needed for placing any Straumann dental implant. The layout of the upper tray has three horizontal areas. The lower area contains all the instruments needed for the basic implant bed preparation. Here there are two lines of drills, located one above the other. There is a line of tapered drills used for the bone-level tapered implants, and a line of non-tapered drills used for all other Straumann implants. For ease of use, pictograms indicate the respective drill lines. Alignment pins and depth gauges for checking the accuracy of the basic implant bed preparation are also located in this area. The same pins and gauges can be used with both tapered and non-tapered drills. The middle area contains all the instruments required for the fine implant bed preparation. These are profile drills and taps. In the upper part of the layout, in the grey inserts, one can find auxiliary instruments used for the implant insertion and the spare instrument holders. At the bottom left, three round burrs are stored. They are used for flattening the alveolar crest, for marking the implant bed position, and for enlarging the entrance hole. The 2.2mm pilot drills, both tapered and non-tapered, are stored in the blue inserts. For each drill, there is a short and a long version depending on the available space in the patient's mouth. They are used for the first implant bed preparation. The 2.2mm alignment pins are also located in the blue inserts next to the pilot drills. Alignment pins are used for checking the depth and the axis of the prepared osteotomy. Following the colored workflow line leads to the yellow inserts, where the 2.8mm tapered and non-tapered drills, as well as the depth gauges, are located. Again, there is a short and a long version of each drill. The yellow color code corresponds to the color code on the lid of the ampoule for implants with an endostele diameter of 3.3mm. These drills are needed for enlarging the first implant bed preparation, while the corresponding 2.8mm depth gauges help to ensure the correct three-dimensional implant positioning. For an implant with an endostele diameter of 3.3mm, basic preparation ends here. Following further, the colored workflow line leads to the red inserts, where the 3.5mm drills and depth gauges are located. The red color code corresponds to the color code on the lid of the ampoule for implants with an endostele diameter of 4.1mm. These drills are used to further enlarge the implant bed, whilst the corresponding depth gauges help to ensure the axial alignment. This is where the basic implant bed preparation ends for implants with an endostele diameter of 4.1mm. Finally, the colored workflow line leads to the green inserts, where the 4.2mm drills and depth gauges are positioned in a standard arrangement. The green color code corresponds to the color code on the lid of the ampoule for implants with an endostele diameter of 4.8mm. These drills are needed for final enlargement of the bed when an implant has an endostele diameter of 4.8mm. Basic implant bed preparation ends here. After the basic implant bed preparation, the colored workflow lines lead to the profile drills, which are required for fine implant bed preparation. These drills help to prepare the implant bed according to the coronal aspect of the implant design, the implant type, and diameter. Profile drills are available in a short and a long version. Following the colored lines will lead to the drill that should be used with the specific implant line, provided such an indication is relevant. For example, the S, the standard implant line, does not need a profile drill, but a BL, a bone-level implant, requires one. Each drill is identified on its shaft. The workflow lines further lead from profile drills to taps, the instruments used for the final implant bed preparation. Tapping prepares the implant bed for a specific thread type. It's an optional step that provides flexibility to adjust the surgical protocol to the bone class to help achieve optimal primary stability. Tapping is recommended in dense bone with large diameter implants. The tap compartments in the cassette are clearly marked, and the color-coded system indicates what implant diameter the taps are used for. There are 3 types of taps: for the standard and standard plus implant lines, for the bone level, tapered effect and NNC implant lines, and finally the taps for the bone level tapered implant line. All taps are identified by marks on the shaft. The workflow lines navigate the user from a profile drill to a specific tap according to the surgical protocol for the implant. In the upper part of the cassette layout, there are several compartments with grey inserts. The instruments in these 4 compartments are available in 3 lengths. Here there are handpiece adapters, which are used to pick up and insert the implant with a dental handpiece. Just below, the adapters for the ratchet are stored. Next to the adapters, you'll find the SCS screwdrivers for the handpiece and for the ratchet. These are indicated by the corresponding pictograms. SCS screwdrivers are used to pick up healing caps and healing abutments. They improve efficiency by connecting caps securely to the screwdriver and safeguarding them from being accidentally dropped. The same SCS screwdrivers can be used for handling the impression components and most other Straumann prosthetic components. The remaining grey inserts are left for other instruments that the clinician may need. The lower tray of the surgical cassette is set aside for storage of the diagnostic T, the distance indicator for bone level and tissue level implants, the ratchet, the torque control device, the holding key, and short and long tweezers. After surgery, residues of blood, saliva, tissue or bone must be removed from the instruments and drills immediately. For cleaning the drills by ultrasound, the Straumann ultrasonic cleaning cassette can be used. The ratchet must be disassembled for sterilization and storage. The brochure Care and Maintenance of Surgical and Prosthetic Instruments contains more detailed information.